Kia ora koutou. We'll get underway. It's now 1 o'clock, and I just want to welcome everyone to the New Zealand Dryland Forest Virtual Workshop. My name, for you people that don't know me, is Shaf Van Bellicum. I chair the NZDFI, and I'm the General Manager of Proceed, which is New Zealand's largest forest seed producer and a founding member of the NZDFI. It's a Ngāi Tahu-owned business. The other three founding members are, of course, the University of Canterbury, Marlborough Research Centre, and Vineyard Timbers. The partners are really delighted with the response. We seem to have over about 120 registrations today for this workshop, including 12 from Australia. It's a broad group, including people from MPI, forest companies, consultants, universities, regional councils, as well as the wine industry. And I do note somebody from Coal Action Aotearoa is with us as well. So the topic today is developing a sustainable hardwood industry in Marlborough. And over the next 2.5 hours, we invite you to join us on a virtual field trip as our team presents the key aspects of our program with emphasis on durable wood products for the Marlborough region. The workshop itself will consist of 4 sessions, and at each one we'll visit a different Marlborough site, and there's a mix of live presentations as well as videos. There'll be 3 live speakers today. The first up will be Paul Millen, who's our program manager and will be known to pretty much everybody here. Clemens Altena, our research leader from the University of Canterbury. Marco Lausberg, who's the program manager for the specialty wood program, to which the NZDFI also contributes. In session 1, Paul will take us through the history of the NZDFI and the trial network. And in session 2, we're going to look at the market opportunity for durable posts in New Zealand, and we'll cover the industry viewpoint, as well as the results of our research program. Then session 3, that's all about establishing and growing durable eucalypts. And this is from a New Zealand perspective. And so we'll welcome any Australian views. We'll take it on the chin. And finally, in session 4, the linkages between wood research, wood quality research, the breeding program, and really the final element for us, the production of improved plant stock, so that we can get those improved products out into our forests and plantations, vineyards, etc. Now, there's going to be a short question and answer session, no more than 5 to 10 minutes, at the end of sessions 2, 3, and 4, not after session 1. And you're invited to type your questions in using the Zoom chat facility. And these will be addressed by our panel here today. That's Paul, Clemens, and Marco. Please note, we'll have a short comfort stop after session 2 at around 2:20, approximately 5 minutes. But we want to try and keep to time throughout. But if we have some time left over at the end, we're happy to take more questions if there's still interest. In the event that there are some technical issues, please bear with us. If you're experiencing any video lag at your end, there's probably not much that we can do about that, as the workshop is being delivered via the university's ultra-fast sort of broadband. So finally, before we get underway, I'd also like to thank in advance some other people that you'll see in the videos. David Boone from the Greater Regional, Wellington Regional Council, Gerald Hope, the Chief Executive of the Marlborough Research Centre, also a founding partner in the NZDFI, Christo Saggers, who's a trial host, Bridget Ennals from the New Zealand Wine Sustainability Guardians, and Max Gifford, owner of Stembridge Vineyards. So on to our first presenter, Paul Millen. And remember, can you keep your questions to be delivered at the end of session 2? So take it away, Paul.
Hello to you all there. I'm just getting set up. I hope my screen you're seeing now that the start of my program. Thanks, Chef. thumbs up. So fantastic to have such a wide interest. Chef's already mentioned the Australians over across the Tasman, so welcome along, and really good to see those from throughout the country as well, and the diversity of organisations and people that are joining us today. I'm going to take you through what's the NZDFI's vision and goals for our program. The vision's simple, really. We want to be home to a multi-regional, sustainable, durable hardwood industry worth over $1 billion annually by 2050. It's an aspirational vision, as visions need to be, and I'm going to talk about how I believe we as a nation can get there. We've got two key goals. First is around 12 durable eucalypt wood supply catchments that are planted by 2050 that will start producing a sustainable log supply for a future network of strategically located regional sawmills and wood processing businesses. And alongside that is that we want New Zealand's forestry industry to be recognised internationally for improving durable eucalypts by breeding and for its production of high-value hardwood timbers and products. Here's the focus on high quality, naturally durable hardwood for many existing markets that we've already researched and identified. Everything from sawn timber, posts and poles, engineered wood products, and the likes of timber needed for cross arms on power poles and decking and wharf timbers that you can see in these photos. And Clemens will talk more about that later in the session. Back to our key goal, which is these 12 wood supply catchments that we want to see planted in NZDFI's target regions. The concept of a wood supply catchment's based on a centrally located 5-hectare industrial site that's intended to be a future site for a small to medium-sized hardwood processing business. And you can see in the photo here, or in the map here, there's 12 of these distributed, 11 in the North Island, and just one at the moment we've shown up in Marlborough, which I'll be having a closer look at shortly. Each of these is located at a place where we consider there will be adequate land. Either it's already there and zoned, and it could actually, if we had the trees there, be established today. But there's others that a site will need to be found. The concept is for these sites to be the focus for a catchment of planting of forests that are within 40 kilometres of that site, and that also all of the sites have good road, rail and port connections for log supply to the mills and then transport of hardwood products away from the mills. To give you a bit of a look at the kind of mill that I'm suggesting here, this one is a little bit old and rumpy, I might say. It's back in 2009, Borrell's Mill at Narooma. Some of the Aussies will know where that is in New South Wales, where they, back in 2009 when I visited, they were doing 18,000 cubic metres of logs throughput annually. You can see from the photos, doing a mix of different logs, different species, producing a range of basically sawn products. Some of those products, particularly the cross arms, were being sent to another further processing site, but by and large, there was a lot of product simply being cut at the mill and then going out the door sold. So when you start thinking about what we're aiming to do, we've worked closely with Peter Hall from Scion. He's a specialist in technical and economic modelling, and he undertook a case study working with the Hawke's Bay Regional Council, looking at the Wairoa district as an opportunity for planting new forests for future wood processing with non-radiata species. So the concept that he worked on was a small mill that would process up to 52,000 cubic metres of logs per annum, with the lumber out at around 30,000 cubic metres sawn. You've got to go through the remanufacturing, so you get some losses there down to 24,000 cube. And the higher value products, he's ended with assumptions that say, well, there'll be about 21,600 cubic metres produced of the high value products. It's critical to see that the main assumptions that he's included in his model were that the log price delivered to the mills are $195. So that's the price back to the grower. Obviously, he's still got harvesting and transport costs and growing costs to account for, but that's a reasonable log price. and high value product prices using a price of 1,950 per cube. When you run that analysis and consider how do we supply sufficient logs to make the small-scale processing operation possible, we've used assumptions of a 30-year rotation to harvest, and that at harvest there'll be 500 cubic metres of merchantable logs per hectare. Those are fairly simple figures that you can see in the graph, show that at that mill site, a mill demand of 50,000 tonnes of logs or cubic metres of logs per annum, we need a minimum of 110 hectares planted with around 30 years for the rotation, which means that each region needs at least 3,250 hectares of forest established in order to guarantee that log supply for a future mill. Now, if that's achieved, and here we want to look at the Marlborough catchment as an example, and if you look at the map that we've created here, we've used a lens and zoomed in on the Marlborough region. Some of you will know the region, others may not. What's important here is the centre that we've chosen is Kaituna. This is a location in our region where there's a fairly good size or medium sized pine sawmill already operating. We think there's adequate room adjacent to that for a further mill, and it's an excellent location in our region that would serve the region both for producing wood for use here as well as for export. Picton's just out up here on the north east corner, which has got a deep sea port, and here's Blenheim, our main centre. You'll note this blue area, that's odd for a lot of the mapping we're doing. This is an exclusion zone. It's the Wairau Plains aquifer, which is critical to the wine industry. So the Marlborough District Council's plans they restrict planting in that area. So we don't think that's a problem for our goal of a wood supply catchment for Kaituna, though, is when you look at the analysis that we've done, if you take into account land use land that's classified under the LUC of 5, 6 and 7, as well as existing plantations, we have a total of almost 152,000 hectares that could be suitable for growing eucalypts within that wood supply catchment. If we have a target to plant at least 3,250, but we're encouraging up to 5,000 hectares of planting, then based on our annual planting over 30 years of between 110 to 170 hectares, the total area of that 152,000 that needs to be planted in eucalypt forest for the supply is only 3.3%. So we think that's achievable. Most of the other regions we've looked at, it's very similar. In some cases, even less land as a percent of that 40-kilometre catchment area is needed. You might ask, what's it going to cost to plant the forest? And a ballpark figure based on 2020 figures is between 60 to 80 million over that 30 years. If that's achieved, I want to look at what does that offer? What does that deliver back to the region from a regional development perspective? If you look at it from an economic standpoint, the analysis that Peter's done has generated a figure of a return on capital employed of 25%. That's an incredibly attractive figure in today's economics as they stand at the moment. It's based on a capital setup cost of around 27 million for the sawmill and the remanufacturing, and it does take account of the annual costs associated with the planting. What's also exciting about this is that there's a lot of employment generated, not so much during the planting phase, but certainly once harvesting, sawmilling and remanufacturing are underway. And in fact, we were concerned that to actually achieve the remanufacturing plant, you really do need to have a good number of people who have got the capability to work in these sorts of plants. So that will be a future consideration, obviously, in any of these regions who embark on a planting program. What's really promising is the figures that we can see from a mill operating at full capacity based on our wood supply catchments is an annual regional gross domestic product of 82.5 million based on 2020 costs and revenues. So if you take that back to the national level and see the opportunity we've established as we see it for a durable hardwood industry, if all 12 of these wood supply catchments were planted, we'd have 60,000 hectares we'd need, and that would generate sufficient logs for the 12 businesses, 624,000 cubic metres, and generate production of 360,000 cube of hardwood lumber. Later on, you'll hear from Clemens about the market opportunities we see. We don't think it's too much of a stretch that if we were producing this amount of timber, even today, that there'd be adequate markets that would be keen to buy the wood. If you bring the 12 together, that's where our $1 billion industry comes from. If we were successful with establishing all 12 catchments, and look at the direct employment, almost 2,500 FTEs. But we're not really needing to just wait for big mills or even small to medium-sized mills to be established. One of the things that motivated me right from the get-go was that there were already people in New Zealand with the capability to soar up New Zealand grown hardwood. And while we're not talking the bigger mills that I've just discussed, but smaller sized operations, all of those already, there's quite a number of them producing timber, a lot of it from eucalypt, and it's available if you know who to contact and can work with some of these smaller producers. NZDFI has been establishing trials and undertaking research in our target region since 2008. I'm sitting here today in the Marlborough Research Centre, which is where we got underway, and many of our trials are here. This one shows the Avery property, one of our progeny trials down south in southern Marlborough. Extensive amount of research has been conducted there, measuring diameters, heights, taking cores, etc. We'll talk more about that in the workshop. We've got an extensive trial network now across the nation. It's particularly in the North Island and, as I've said, in the top of the South and Marlborough region. 37 landowners whom I'm extremely grateful for the land and the assistance and support they provide. And within those sites are a large number of pedigreed families for breeding, as well as extensive permanent sample plots for assessing site adaptability and productivity over time. So I'll finish there, and we're going to move to our first set of videos. The first one's Graham Boone speaking about the Wairarapa and the opportunities he sees in the Wairarapa from a Greater Wellington Regional Council point of view, and then followed by Gerald Hope, who's speaking on behalf of the Marlborough Research Centre Trust as to why it's involved, and then we'll be setting off on our first field day.
The Regional Council and the New Zealand Dryland Forests Initiative have been working together for quite a few years now, and the Dryland Forests Initiative has been providing that science engine to make sure that there's a strong science base for species selection and understanding how to provide the wood stock for a sustainable hardwood industry. And with that background of work that's gone on, the timing is now right to expand these trial sites into potential industry scale production sites for a reliable, sustainable hardwood industry in our region. So we're in a space in New Zealand these days where resource management is changing at a rapid speed, with national policy and expectations of managing land resources differently. With national policy statements and community expectations around water quality and appropriate land use, that means that catchment communities and the people managing these land resource challenges need options and tools available. We're seeking to be able to provide reliable, very science-based technical information of species that will grow in this environment. It's future-proof with climate change considerations as well. It's another option to pine. Radiata has its place, but diversification across the landscape is quite important. And with a durable hardwood industry, we're seeking to have a supply chain created and a market that is solving the chicken and egg scenario, where we have a hardwood resource planted in the ground but no market to accept those trees, in the industry production side of things, or the other way around, where you can, the industry production's there, but the tree resource is not in the ground. So pulling this all together is the exciting opportunity we have with this initiative.
Marlborough Research Centre's had a 36-year history with the primary sector. We back innovators, we back the people who actually put projects up for our consideration. New Zealand Dryland Forests, that was one we selected 12 years ago, and we've allied ourselves with that project over the period of time. We seed fund, we back the people who are actually going to manage the project, and we give them the support they deserve to get these innovative new ideas into the marketplace. Marlborough is the bulk of the New Zealand wine industry. 80% of our exports come out of this region. However, from an environmental point of view, there is one thorn in our heel, and that is the disposal of and use of CCA treated timber. New Zealand wine growers, sustainable wine growing, they realise this, and they also have encouraged vineyards to convert to durable hardwood, steel in some cases, or other synthetic material which is recycled. MRC recognises that the continued use of CCA treated posts is not viable. The consumers want to know the source of the food, their wines and other beverages. They also want to know just how our production systems are set up. My preference and MRC's support proves that durable hardwood is the future. We just need to have the plantations in the quantity to actually supply the industry. Our estimates for the breakage of vineyard posts ranges from 200 to 900,000 posts per year. You can take 1% or 5%. That's a lot of timber stacked up somewhere waiting to be disposed of. I'm optimistic that durable hardwood will find a place in the market in the near future. It's just not about the horticultural industry. It's just not about vineyards. It's about durable hardwood, which can be used for building, construction, and treated with the respect that a good hardwood deserves. Since MRC became involved in this project, we've been staggered at actually the interest that's been shown. It started out very much as a dry East Coast alternative crop, to put on our harder country. The support locally was, very keen. New Zealand has actually woken up to this being a viable crop for other areas. So it's from Northland to Marlborough, and every region on the East Coast in between. The whole of New Zealand could benefit from this crop, and I think the time is right now to select the best species, get them in the ground, and get the industry up and going.
Welcome to the New Zealand Dryland Forests Virtual Field Day. It's Wednesday the 10th of November, and we're in the Marlborough region to show you some of the research and development being undertaken here in the heartland of the wine industry. Marlborough's a place that's renowned for Sauvignon Blanc. It's a wine that's drank throughout New Zealand and throughout the world, and it's been a significant development in the last 30 years in this region. As you can see behind me, we're looking into the lower Wairau Valley. Out to the east is the Wither Hills, and in the far distance is Cloudy Bay. One of the wine labels you'll know is Cloudy Bay Wines. And then further across on the landscape are the hills of Mount Richmond Range. This beautiful valley was once filled with farms and shelter belts, and were a part of what was a large sheep and cattle industry. But from the 1970s, with the introduction of wine growing at scale by the company Montana, the success of that industry has resulted in there now being well over 30,000 hectares of vineyard in this region. By 2003, there were 10,000 hectares already of new vineyard in Marlborough. These vineyards made extensive use of treated pine posts, and these became of concern to local wine growers. As a result of this concern, my brother Ash and myself decided there was an opportunity to grow naturally durable eucalypts to produce vineyard posts that didn't need treatment. We established Vineyard Timbers Limited, and we then approached the three other partners to the program that include the Marlborough Research Centre Trust, which is based here in Blenheim in the valley behind, as well as the University of Canterbury, the School of Forestry. We approached them and they became interested in a research program. The other key partner is Proceed New Zealand, that are owned by Ngāi Tahu and based in Christchurch and are specialists in tree seed production. Today's field day, we're going to take you on a tour to visit a number of sites so as to see some of the very early trials that we did. They were informal trials just to try and find out what species could be suitable, as well as some of the trials that we established once the NZDFI was formed in 2008. The first stop where we are this morning is actually in one of those first New Zealand Dryland Forests Initiative trials planted in 2011 at the Sagers property, which is here on Ben Morven Road, as I've said, overlooking the Wairau Valley. To the north of us, across the Wairau Plains, are the hills of the Mount Richmond Range, where the rainfall out towards the east is 1200 millimetres per annum, and as you go further west can increase to 1500 to 2000 millimetres per annum. Whereas here we are about 20 kilometres as the crow flies from those hills on the bare hills of the southern part of Marlborough, and the rainfall is less than half of that. The other significant climate variation in this valley is the mean annual July temperatures. How cold does it get? And when you look out to the east on the coast, it's much warmer, much lower, much less likelihood of frosts. And as you move up the valley to the west, heading for Nelson Lakes National Park, it drops off many degrees, and so that winter temperatures are a lot lower and a lot cooler. This variety of climate variation in Marlborough means we've got trials deployed into a lot of different localities that allow us to undertake research into the success of growing these species in these different environments. This is a demonstration trial that was planted in 2011 by the NZDFI. The trial's key purpose is to understand species adaptability and survival. How well can each species grow on a tough, dry site like this? The other key purpose of the species is to demonstrate to possible growers what a eucalyptus trial block of trees can look like. We have many of these trials throughout the country. They are very important for understanding and being able to produce site species matching so that we can encourage growers to plant species that are best suited to their locations. There's 11 species being evaluated in this trial. They're planted in blocks with 3 replicas per species. Combined with data from other sites, we're able to understand what are the environmental drivers to their survival and long-term productivity. In order to do that, we have established permanent sample plots, PSPs they're generally called, where regular measurements allow us to gather the data that we need in order to produce these site species matching models as well as growth models into the long term.
I'm Christo Sagers and I live here at 213 Ben Morven Road in the southern hills of Marlborough with my wife Jenny and my 3 children, and we have 70 odd acres here, about 30 of dry hill country and about 40 in Sauvignon Blanc. The main observations of these species is that they establish very quickly on a very dry hill site. They tended to grow faster initially than the trial pine blocks that were planted at the same time, and they were surprisingly healthy with very few deaths, even though we had very dry summers. And yeah, just the rapidness of the growth is just outstanding, really. I can't believe they're only 9 years old, and some of them are sort of getting on for 10 metres. I would have thought 8-10 metres, and yeah, just blown away by how fast they've grown.
So before we sign off here and head off to our next stop, I'd just like to acknowledge Christo and Joe Sagers. They, along with the many other landowners that support the NZDFI, make our research possible, and our landowners now range from up in Northland to right down to Canterbury. So any of them who are watching today, thanks very much for being part of the team.
Okay, that's our first set of videos. I'm going to now give you a quick introduction to the NZDFI's website. This is a pretty key part of our of what the DFI have available for anybody who's interested in our program, and it's a pretty extensive website. I think of it like a library, and in that there's a whole lot of shelves in there with different information depending on what your interest may be. And so I'm going to quickly whip you through that. Obviously, there's a home page which we're sitting on there, and there's the usual information about the NZDFI if you want to know more about our strategy and the people involved, and where our funding, etc., comes from. That's covered off in there. But if you're in the science and research side of things, we've got a couple of tabs there, so our science and research that cover all of the work we're doing on tree improvement, the selection of our species and seed collection, our breeding trials, etc. And then the key research priorities, particularly the wood quality work that is being led by Clemens and his team at the university, and then others at the university, Steve Pawson working in eucalyptus health, and Ewan Mason and Justin Morganroth, who are working with site species interactions, and then the propagation work are underway by Proceed at Amberley at their facilities that they have there. If you want to see more about our websites, about our trial sites, there's quite a bit of information there, including what some of the landowners feel about being involved in the program and what their objectives are. For those of you who are keen on just getting out there and planting some trees, this is probably for growers is one of the most extensive parts of the website. This covers a lot of information about right tree, right place. You know, why would you grow eucalypts? The vision I've talked about in our strategies, regimes, as well as choosing the right species. And I'm going to come back to that a little later in our program. And then for those who are really wanting to dig into it and see some publications or watch some other videos and seminars that we've been involved with over the years, we try to keep most of that under our resources tab. So if you've got questions, this is the first point of call. Get yourself onto the website, get familiar with it. There's a lot more information in here than I can probably, and we can certainly deliver today. So I hope you find it easy to get through that.
Thanks, Paul. And I was just going to say, let's just move straight into Clemens. I was just having a bit of trouble with the video. So take it away, Clemens.
So I will just lead directly into the second session, and where we discuss a little bit more about the market opportunities of durable eucalypts with a New Zealand perspective. There are basically three categories of products which we are targeting, making use of three different exceptional properties of our species. That's durability, their appearance, and also their exceptional mechanical properties. And the first category of products is really making use of the durability, the natural durability. And it's outdoor timbers. So in New Zealand, that's typically CCA treated pine products, and we can separate it into broader groups, and that's sawn timber, mainly in a residential setting for decking and maybe cladding and so. But there's also the agricultural sector, which uses posts for fences, but also trellis systems and so on, which uses a lot of CCA treated timber. So we can make use of our durability and substitute into those markets. We looked at the size of those markets, and they are about 300,000, 400,000 cubic meters per year, and that's each of them. And that's the amount of CCA treated wood produced annually here in New Zealand. So some of that we can certainly substitute with our durable timber. Now, considering the price at the moment, $700, $800 for a cubic meter of CCA treated timber, that is probably a lower bound for what we can obtain for naturally durable timber, which most likely will sell at a premium to that. And, oops, sorry. The next group of products which we are looking at is hardwood timbers, really making use of the color, appearance, texture of the wood, sawn timber. And there's also quite a bit used here in New Zealand, and it's a lot of this timber is imported. While New Zealand produces a lot of timber, and it's typically radiata pine, and we export it as logs, but also as sawn timber. We also import timber, but it's different type of timber. They are typically hardwood imports. And one striking difference between our imports and exports is the price. So the timber we import is about $1,400 per cubic meter, and the timber we export is around $400 per cubic meter, so a $1,000 difference. And there's no reason why we can't substitute some of these import with the timber we intend to grow here with our durable eucalypts. Now, this demand for high quality hardwood is not only here in New Zealand, it's a global demand. And demand is, if anything, increasing. What's really a problem at the moment is that there's a real pressure on the supply side. So a lot of these durable color timbers come from tropical forests, which are diminishing and are often unsustainably harvested and logged. But also, if you look directly over into Australia, there's some pressure on the supply of Australian hardwoods from the recent forest fires over there. So we think there is not a big ambitious task to export maybe 100,000 cubic meters per year of such timber if we would have the timber available. At the moment, we just don't have the timber here. It's probably more difficult to do it on a smaller scale because for export, you need to have a certain critical size to make it viable. And the last type of products is making use of the exceptional strength and stiffness of those timbers. They are maybe twice as strong and stiff as radiata pine. And therefore, they lend themselves to make engineered wood products, such as laminated veneer lumber or plywood. To manufacture those, first rotary peeled veneers are produced, and we have shown that we can produce those veneers. They are exceptionally good mechanical properties, and these industries already exist here in New Zealand, and they also trade just the veneers. That's not here prices for the final products. It's prices for the veneers, and they are around 400 to 500 cubic meters dollars per cubic meter. And that's again probably a lower bound which we have here because the price is really related to the mechanical properties, and the veneers we can produce exceed basically everything or what is traded currently, at least in New Zealand. So while there is a market for those timbers, we also need to think about, is it economic viable propositions. So how we have approached that, we have looked into the value of those products coming out of a tree. So we know the size of our trees, we know the amount of hardwood, we know yields, or have estimated some yields, and then we can assign what's the value of product in a tree. And then the other thing we know is how much does it cost to grow those trees, including already a profit for our growers of 8%. And in all the cases we looked at, where the value in the tree as products was much higher than our growing costs. So this difference here would need to cover harvesting costs, transportation costs, and also the profit for the wood processors and the wood processing costs. Yeah. So with that, I want to take you on another virtual field day stop, and we will go to a vineyard, Stembridge Vineyard, where we'll hear from the wine industry people and what their demands on durable posts or on posts is. Thank you, Monica. You can start the next video.
Welcome to Stembridge Vineyard. I'm here with Max Gifford, who's the owner of the vineyard on my right, and also with us today is Bridget Ennals, who's the Sustainability Guardians Coordinator for New Zealand wine growers. We're in the vineyard here today to have a look at some of the posts that are now being potentially produced for vineyards out of naturally durable eucalypts, and also to hear from Bridget about some of the issues that they do have with the current use of chrome, copper, arsenic treated pine posts.
Hi, so I'm Bridget Ennals from New Zealand Wine Growers. I'm the Sustainability Guardians Coordinator. So New Zealand Wine Growers is the industry body for grape growers and winemakers, and they run a program called Sustainable Wine Growing, which is based on 6 focus areas: waste, water, soil, climate change, people, and pest and disease. Growers and wineries are audited against the guidelines and accredited accordingly. So in New Zealand, on average, there are about 40,000 hectares of grapes being grown. Historically, CCA treated timber has been the preferred trellising used. So CCA treated timber is timber that's been treated with chromium, copper and arsenic to prolong and preserve the life of the post. One of the issues we do have with these posts is that they can break during mechanical harvesting. Some growers have reported between 2 and 5% of posts that are broken on any given year. So that equates to approximately between 11 and 29 posts that are broken per hectare on a vineyard that has a row spacing of 2.4 metre width and 1.8 plant spacing. So as a minimum, if we were to say that 80% of vineyards in New Zealand are using CCA treated timber as a trellising system, that would be a minimum of 370,000 posts that are being broken on an annual basis. In terms of disposal of these posts, it's actually quite problematic. Because they have been treated, wineries are unable to burn them. In fact, it creates toxic fumes and toxic ash. The posts cannot be mulched or composted. And the best way of disposing of the posts is either sending them to landfill, which doesn't really sit well with a lot of people because we're trying to minimise the waste that we send to landfill. Or the other option we do have is to burn them in a pyrolytic burner, and where the posts are burnt at extremely high temperatures and they're able to scrub out any toxins. But there is only one accredited facility here in New Zealand, and that's based in the North Island, and so is not really economically viable at this point from the southern regions. So basically, growers stockpile posts in the hope that they can find a second life for them, So they sometimes get reused in landscaping projects. And there is a company out based here in Marlborough that point posts and on sale to farmers. Growers are looking for long-term sustainability, environmentally friendly products, looking for a post that's durable, that has low emissions to produce, that is cost effective, and is easy to dispose of end of life. Growers are really keen to try hardwood posts. At the moment we have supply issues in terms of the only available supply is really coming from Australia, and growers are concerned about the cost of that and also the emissions associated with transportation to here. So if we can have a hardwood post that is grown here in New Zealand, I'm sure it's going to tick a lot of boxes.
I'm Max Gifford, the owner of this vineyard here, Stembridge Vineyards. It's an 80-hectare block, and we first started off in the late 1970s, so it's about 42 years of grape growing. In our vineyard we have probably about 400 broken posts each year, and it's really quite a major problem we don't really want. I mean, we start off straight after harvest and we go through and touch basically every post to find out whether it's broken. That one obviously is. So then we have to go through and remove the nails and remove the post, put in a new one and re-nail it. And so 400 times, that's a big job. And walking 400 up and down each row to find them's a major job. So we're really keen on finding an alternative. There is a bit of a swing in Marlborough to steel posts, which does eliminate the broken post problem, but they aren't perfect. A steel post is quite a small diameter and they don't have the width to withstand strong winds and a heavy crop. What happens, the whole post starts to lean like that. And so the only cure for that is to go along and put a block of wood or something in front of it to hold it back, and that's another major job we don't really want. We've tried plastic posts. There's some behind you there which are a disaster for us. The later ones I think are probably much better. So Paul got us interested in putting in the eucalypts post that came from Australia about 11 years ago. And so far we've had virtually no breakages at all. So they definitely have a place in the vineyard. I think probably you'd still want to have the odd half round, maybe every third post needs to be a half round to get that width to withstand the winds, unless we get our eucalypts quite, larger scale. The things that probably matter to a grower is, you want that surface area. The price would have to be right, because everything's in thousands. They need to be easy to put in. And another thing is, grape growers tend to be quite fussy about things looking right, so they need to look okay. We don't want a great hairy old thing, bits of post sticking out the side. And it looks like the eucalypts we're getting now are fine, they're very good.
I'm Clement Saltana from the School of Forestry, and I'm a wood scientist. I'm involved with the New Zealand Dryland Forests Initiative since about 2009, and in the recent time we also do some work on processing these posts. And the first posts which were also installed here in this vineyard are these square posts, and they came from a really old Eucalyptus bossuana tree and globoidea tree, and they were cut with a sawmill. And we can't really produce these square posts from small diameter trees, and in our case we don't have really big trees available at the moment, so we need to manufacture them from smaller diameter trees. And that's what we've done in the last little while. We used conventionally available machinery to see if we can use these high density, very strong, hard eucalyptus logs and produce them into posts. And here we have 3 posts which we manufactured with a conventional post peeler. And they all came from one Eucalyptus posistuana trees, and there were actually 5 posts coming out of a tree of that size. We used 2 different machines for doing that, and they are really small scale machines which you can either move to your stand, so have it like a mobile saw and bring it to the resource and processes, and also a little bit a larger one where you can have higher production rates as well. Both of these machines, they were well able to make posts with good surface. They really look the same as you would produce them from radiata pine or any other softwood for which those machines have been designed. And there was no problem with the hardness and the density of these eucalypts. What was a challenge was this really thick bark which these trees have, and only when they were debarked logs that worked. If the bark was still on the logs, the machines had real trouble. And that's not so much of a problem, because when you fell trees, mechanically you can easily remove or debark the logs, or there are other machines which can take the bark off. Really good about producing posts from small diameter trees is that it's a high value product which is made from a really low quality tree. Small diameter trees are typically of low value, often used for firewood or just fiber pulp. But if we can make posts out of them, that's a high value product. And additionally, we can produce round posts at reasonably high yields. There's hardly any wastage which we have from that. And that's in contrast if we make square posts from big trees by sawmilling, the conversion rates are quite low. What's really good about manufacturing posts as well is that we have machinery which is able to work on really small scale. So having a mobile unit going into the stand, almost like a hobby business, but it can go to really large scale. And we have already an existing post industry in New Zealand based on radiata pine, but these machines can also deal with our eucalypts. So it is a really easy entry industry, because we can just slowly phase in the durable eucalypts when they come available into an existing industry, or we can establish small scale new durable post producers. That's very different to a pulp industry, for example. If you want to build a new pulp mill, it's $1 billion investment, and it's 1 million cubic meters of wood going into these mills, and you need an appropriate sized forest to it. So that's not an easy feat to do. Now we are in a vineyard where one of the posistuana posts had been installed 15 years ago, and we took the opportunities 4 years ago in 2017 to assess 50 posistuana and 50 globoidea posts for decay. And how we do it, we just remove some of the topsoil, and then we look at decay here. And why do we look just in the topsoil? It's because that's the most dangerous zone for the wood. It has moisture and it has oxygen, and both moisture and oxygen are required for the fungi to survive. Further down there will be no decay because there's lack of oxygen, and further up the wood will be too dry. So remove a little bit of topsoil, and if there's a fungi growing in the wood, it will become soft. So we make just a poke test, and we put a knife or something to it, and we see the wood is still rock solid. So even 4 years on, this post shows no sign of decay. It has now lasted 15 years. I can show you some other sample here, and breakage of the post is a problem. For radiata pine posts, it's 2 to 5% of the post breaking, but for the eucalyptus posts, there were hardly any broken. Some posts broke right at the start, so that is a post which we dug up in 2017 after 11 years, and it was broken at the top, as you can see, but it broke here because of a knot which was in the post, and it's an issue of quality control. So if we have more posts available, we need to do a proper grading regime and exclude posts, and then we don't see that breakage. In any ways, this piece of wood, you can see after 11 years in the soil, it's still solid, nothing has decayed, and it's easy to dispose. You can just use it as firewood, or you can plane it down and use it for something else if you like.
So having been out here in the vineyard, it's been great to see the hardwoods being used. There's been hardly any deterioration in the wood, which is really good. And I think it's really the way forward to have hardwoods grown in New Zealand.
A very exciting alternative to the normal way of producing posts is actually combining it with rotary peeling veneers for plywood or LVL. So we have an existing LVL and plywood industry in New Zealand, which is based on radiata pine, and they use big logs, and they turn the logs around, put a big knife to it, and then they peel veneers from the logs like those, and then they are glued together into products which are called plywood or LVL, and I have a sample here. So during this this process, we are not only making veneers, but there's also a byproduct, and that's the peeler core. It's just where the center of the log was, and it was held in the lathe. And these peeler cores, if they are from radiata pine, they are basically only used as firewood or as fiber for the MDF industry. But if it's a durable eucalypt, that's a really nice round post which we get as a byproduct. And this byproduct has the same value, or maybe even more valuable than the veneer itself, which is peeled from these logs. And the rotary peeling has another advantage as well. It's a very high yield operation, so we can convert a lot of the wood which is in the log into product, veneer, and then even the posts. And making these veneers, and this is a Eucalyptus posistuana veneer, which we have already glued up into Eucalyptus posistuana LVLs, that the mechanical properties, the structural properties of this timber is very high, very strong. So it's very stiff, very strong wood, which makes exceptionally stiff products. And the timber engineers wanting to build bigger and bigger timber buildings, they really ask for this higher stiffness engineered wood products. And they can be manufactured from our trees. They cannot be manufactured from radiata pine, because the radiata pine wood is not that stiff. And again, because we have an existing radiata pine, LVL and plywood industry, we can slowly phase in our eucalypts. We have shown that they can be peeled within these mills with the standard equipment, and we can slowly phase them in and either making exceptionally stiff products, or we can mix them up with the radiata pine and just lift the properties of radiata pine products by incorporating a little bit more stiff veneers from our eucalypts. And the byproduct would be the posts. Now we hand over to Marco Lausberg.
Thanks, Clemens. Just confirming, can you see my full screen there?
Yes, I do.
Excellent. All right, thanks very much. Yeah, so my name's Marco Lausberg. I'm the project manager for the Specialty Wood Products program. So that we also looking at Douglas fir and cypresses, but today we're talking about eucalypts. I've got a very brief presentation on a field visit I had. Why am I not going? There we go. We were hosted by Super Forest Plantations in New South Wales back in October 2019. And I'm just going to talk a little bit about their commercial thinning and peeling of the logs they're producing. So they've got these aren't trials; these are commercial stands. So they're a mixed species. You'll see the list of 7 species there, which actually makes looks much more like a natural forest than a plantation. But that's the main species they're working with. They have set up what's called a spindleless lathe. So this has the ability to go to a much smaller diameter peeler core than a standard lathe, which is as big chucks on either end. So that's the real benefit of a spindleless lathe, is it can go down to quite small diameters. As with Clemens, as he mentioned earlier, they found it's very critical to remove the bark beforehand. So it really clugs up the lathe if the bark's not removed. So that's key. And currently they're peeling to a set diameter of 100, I think, around 100 millimeters. And the roundup from these logs, which is the veneer, is just being used for mulch currently. It's not being used for plywood or anything like that. A real rough estimation of the price for setup was around 300,000 Australian, I think, for this, and then you have to add on several tons of blood, sweat and tears, as James, who has been involved, can attest to. But they've done a very good job. And an operation like this could just be set up standalone in terms of processing peeler cores. It doesn't have to be tied to a sawmill or anything like that. So you can see here, this is the lathe here. So I'm going to start the video, but you can see that basically it has 3 rollers. There's 2 rollers, one above the other here, and a third one on this side. And the log is held between those 3 rollers. The knife runs along the bottom here, and that way you can keep coming and peeling smaller and smaller until these rollers come very close together. So you'll see that as we're going. So the log comes in from the peeled, the debarked log comes in from the left here. And the machine opens up, lets the log get inside and gets centered, and then starts peeling. And you'll see as it gets down, it starts peeling much more evenly once it gets the log round. And peeled to, they get down to the hardwood. So you'll see here fires off down to the left, and higher up on the screen here there's a conveyor belt where the waste is coming out. You can see a piece there. They just peel down to their meters, and then the cord is dropped out and rolls along the outfeed there. So they've got obviously spent money on the infeed and outfeed and the shed and that sort of thing. So there's quite a bit of, it's not just buying a lathe, you've actually got to buy the handling system as well. And in the photos here, you can see that's a picture of the veneer. Those lines on the diagonal are actually the lines off the rollers there. And there's a couple of examples of the different poles here. So the next slide, these are 5 species that you can see that they've trialled: blackbutt, ironbark, spotted gum, messmate, and the red mahogany, which was the one you saw go through the lathe just before. So these are all class 1 or class 2, obviously highly naturally durable. And James, who I think is one of the people on the presentation today, he's available for questions. But also, before I forget, I'd like to thank them for hosting us on that site visit and also making the video and photos available. And lastly, he's got 4,000 odd posts now of mix of these species that they're keen to trial. So he'd be keen to hear from people who are interested in seeing how well these perform for their horticultural or other uses. So feel free to give me a yell, and we can set up that contact. So that was a very brief presentation there, but really keen to hear from people. And I'd like to hand it back to Clemens now, who's going to talk about the practicalities of handling these durable posts and poles. Let me just stop sharing.
Yes. So now we go back to the Stambridge vineyard, and Monica will show a video where we think about other practicalities of the posts. One thing about these eucalyptus posts, and that's again a Eucalyptus posistuana peeler core post, is that the wood is very hard. And we were wondering, is it actually possible to use the standard fencing equipment of staple guns to put in the staples which are used for fencing, or also in the vineyards maybe? Because if they have higher hardness, it's more difficult to get staples in. So we use the standard staple gun for fencing and use the standard radiata pine staples, and we got the staples all in. That worked reasonably well. We got the larger ones and the smaller ones. They went in very well. Or let's say they went in behind the barb, and it's very important that they go in behind the barb because that is what holds them in. But they didn't penetrate as much as in the radiata pine posts. There are two types of staples. There are softwood staples and hardwood staples, and the softwood staples are a little bit longer, 50 millimeters, and hardwood staples are only 40 millimeters, and they are not available in New Zealand, but they are plenty available in Australia. It's an off-the-shelf product, and if we use those, it's perfectly feasible to use standard fencing equipment to put the staples into the durable eucalypts.
Today I also wanted to talk to you about some of the other applications for durable hardwoods. We are focused today on the posts and the opportunity that we have to grow roundwood, particularly to be used in vineyards. But some of the other applications that are possible that are, if we grow forests for longer term rotations, similar to radiata pine, so as to produce large saw logs. Some of the timbers that I'm going to show you now are the same species that we're planning to use in the vineyard. And when you saw them and machine them, you'll see some beautiful colour and grain, and the properties that make them very good for posts are similar for applications that are both outdoor applications as well as indoor applications. So the first example of another product that our timbers can be used for are for cross arms. This big piece, or fairly big piece of timber here, this is an Australian imported cross arm. I'm not sure how long it's been up on the top of a power pole, but a lot of people don't appreciate that these are sitting up on and carrying the electrical wires that supply power to all of our whole country, and that we've had to import these for many years, and we've never been able to produce them here in New Zealand. One of our goals is for our forests, future forests, to supply New Zealand with power. A second example for potential use of our timber is internal flooring. So for example, this is Eucalyptus persistuana. This is timber from only a 15-year-old tree. It's been planed up and oiled to bring out the grain. And then I'll bring up alongside it, this is Eucalyptus globoidea. Very similar, it's 15-year-old timber, equally beautiful but a different colour. So we also have some pieces here showing a species made up, for example, that could be used in a tabletop or a bench top. This is Eucalyptus quadrangulata. Here's a small panel of Eucalyptus tricarpa. This is ironbark and has a deeper reddy brown colour, very attractive to the Asian markets. And finally, this larger panel, this is Eucalyptus persistuana. It's beautiful grain. Some would say similar to teak, which is renowned throughout the world as a species for all sorts of applications. So I hope you appreciate that there is a lot of other potential uses for the hardwoods that we can grow in New Zealand.
Thanks very much, Paul, Clemens, and Marco. We've now got a short question and answer session, and I see, well, we've got at least two questions here for answering. I'll just put them to Paul for a start. I'll put the first question to you, Paul, if you can hear me okay. Hello, Paul.
Yep, just unmuting.
Yes.
I see the first question's from Claire Ryan.
I'll leave that. No, I'll leave that one first, Paul. I'll deal with the second one first because I think it's a bit shorter.
Yeah.
The question is from Joanne Lewis, and she says, "Hi, folks. What is the expected duration of a CCA treated pine post?"
Well, thanks, Joanna. Nice to have you online. Remember meeting you when you visited a few years back. So it varies in the industry feedback, and Bridget's, I think, online as well, is that you get that breakage of between 2 and 5%. If you said it was 5%, then on average, over the course of 20 years, then every post would break. Okay, so a 20-year life out of a post in a vineyard, the industry's pretty keen to see that. If you could have a vineyard that survived 20 years with minimal breakage. I mean, the breakage we had in Stembridge with the square sawn posts was 1/20th of the breakage that Max would have normally had within his pine with the pine post. So it's definitely within the scope of naturally durable eucalypts to be able to produce a very stiff, strong post that has sufficient durability to give you a 20-year life.
And I can add to that with copper chrome arsenate, you can get much more durable timber, which if you put enough in, it will last 50 years or more in quite severe conditions. But often that's not really needed, and naturally durable timber cannot compete with it. And if you don't need that longer lifetime, then why would you aim for it? The other thing what I hear from the wine industry is that they often replace their wines every, I don't know, 15, 20 years, and put new posts in at that time anyways.
Thanks, Clemens, and also Paul. The second question is a much more not much more interesting one, but may take a little bit more. May take a little bit more to answer. This is from Claire Ryan, and she's with the Coal Action Network of Aotearoa, and she's interested in your views, Clemens, in the first instance, but also Paul. She says, have you considered the biomass market for fast-growing hardwoods? Dairy factories and meatworks are all trying to switch from coal-burning furnaces to viable green alternatives. And high heat-dense hardwoods burn more efficiently than pine. Now, I think she's asking if that's a question as well. So your views on that. Have we considered the biomass market for growing hardwoods? Clemens, I'll start with you, and then Paul, you may want to come in as well.
Yeah, we have been asked about it, and we're thinking about it. And it's certainly the case that these plantations can produce a lot of fuel. And that's because we got, in some places, exceptional growth rates, but also we have this really high density. And I think with the high density will always suit you well in a coal burner or in a furnace like that, because you can get a lot of mass into the chamber. Yeah, so there's an option for it. You probably would grow them in a different regime, but from our case, we are target solid wood products, and that would be used for our byproducts. Parts of the trees which are too small, or the offcuts in the wood processing, which could go into the into energy. But apart from just using it as fuel, there's also the whole question of carbon sequestration, and maybe Paul wants to add to that.
Do you want me to contribute any more there?
Yes, Paul, please.
Definitely. I've been in touch with the bioenergy group, Brian Cox, I think it is, and been in discussions with him in the last few months. And we think it's a real opportunity to be basically growing short rotation, highly dense eucalypt, and having a system where you're harvesting, you're chipping the wood, you're drying it, and it's straight into the furnace. So unlike radiata, to get some of the higher calorific value, the higher heat out of it, it has to be pelletized. In this case, with eucalypts, it's already so dense, you can basically, just as long as it's dry, you can shove it into the furnace and it should go. Already in Brazil for many years, their steel manufacturing, their steel mills are actually not run on coal. They are already run on eucalypt chip wood to fire those furnaces. So there's some real opportunities. What I think is important here is scale, to think that if you've got a factory, if you've got a dairy industry, how do you match the scale? Wood still is a heavy product to move around. So you do want to think about a catchment, a wood supply type catchment, and that's the sort of piece of work. It'd be great, maybe one of our, if there was a business out there that was interested in this, it would be an excellent student project potentially to have us have a look at what would you need to do to make it possible to convert from coal to eucalypt wood chip.
Thank you, Paul. All right, we'll move on. Conscious of time, there's 2 or 3 questions to come. One's from Warwick to you, Paul. Paul, you talked about the scale of planting required to achieve the regional scale required. What area is being planted between 2020 and 2022 or planned? And how are we going relative to that target?
Well, thanks, Warwick. I suspect that's Warwick Lisserman, who's one of our landowners, and he's been involved for a long time. So great to have you along today, Warwick. It varies on the regions. If you look at Marlborough, we've probably got around 200 hectares planted, and that's not in the last 2 or 3 years. That's actually since we really got underway and includes our trials. So we haven't really made a big start on it here. The region which has really got underway with planting is in the Hawke's Bay and also up in Northland. And in particularly the Hawke's Bay, there'd probably be in the order of 300 or 400 hectares already planted, and much of that in the last 5 years. And in Northland, not so much, but certainly in the last 3 years, there'd be 200 or 300 hectares having been planted. Whether those plantings all fit within our wood supply catchments, I can say they probably don't, but certainly there's interest. And some of our other regions, there's been no planting, and in fact there'll be some of those regions won't even have us on the radar, and that's because we simply haven't had the time to get round them all and try and engage. But I like to think of it as being an opportunity that the individual regions will pick up and run with and find their own program to try and promote and encourage what we're providing the opportunity for. We can't go into every region and make it happen. So the regional councils and our engagement with them is, I think, critical to the success, as well as being able to work with the newly established New Zealand Forest Service, Te Uradaka team, and also the various forestry consultants and forest managers that are in those various regions.
Thanks, Paul. Look, we've got 4 questions here. I'd like to get these all answered, conscious of time. So if anybody else has got questions, can you possibly hold them till the end, and we'll see what we can do. The next question is from Robert Miller, and to Paul again. Hi, Paul. What are the limitations of other South Island regions for the NZDFI program? There's already an established euc industry in Southland, admittedly for biomass.
Right. Well,
that's a big one.
Yeah. Well, I'm going to answer it if I can quickly find myself in this list here. And
well, while you're finding that, maybe we could just we'll get another question out of the way for Clements, if that's okay.
Yep.
It's actually to you and Clements, but Clements may want to start this one off. Hi, Paul and Clements. Did you consider to conduct research with other tree species, for instance, Ulmus glutinosa? And that's from Juan Luis Flores Fernandez, I think it is. Pardon my pronunciation. Clements, do you want to try and answer that?
Yes, so we have really focused on eucalypts in this program. One limitation which probably we'll talk about is temperature. So further south here in New Zealand, it will get colder, and there is interest to grow something although in these colder areas, but we haven't looked at Ulmus glutinosa, but it wouldn't be a eucalyptus. Yeah.
Okay, and while Paul's going to come back to us. Clemens, maybe this question, you could answer this one. Hi all, are there challenges when curing and drying peeled posts? Look like some checking and cracking in the examples. Would this be an issue for end users?
That's a very good observation. And yes, if we have these posts, some of them tend to check. And there's also a study out from Australia where they had square sawn posts from with pith from these eucalypts, and they recognized a lot of checking in those as well. So if we seen at the peeler course, some had some splitting, others were fairly okay. If you think about the larger diameter, then I think a strategy against the splitting would be producing half rounds, and the half rounds or even quarters, they would reduce the splitting or should alleviate that problem.
Okay, thanks, Clemens. Paul, are you back yet, or?
Yep. Yeah, I've got this now. So,
okay.
So this is can you see that slide there? If I go.
Yes.
Right. So there's two at a national scale. There's two key climate factors that will define the adaptability of eucalyptus. One of them's in New Zealand. One of them's the rainfall. So this rainfall map shows New Zealand's incredibly variable for where the rainfall where rain falls, and under the legend you can see that the colour spans there. So where the driest parts of New Zealand have less than 600 mils of annual rainfall, and then there's a range of those browner orange through to yellow colours where you're getting up to about 1200, and then you get past that into the greens and the blues, and parts of New Zealand right down the bottom there's actually parts in New Zealand that get over 10 metres of rain a year. And funny thing is, and I shouldn't say it's funny, it's sad for the West Coast, but last night, for example, in Westport, which is over here, they had 160 mils overnight. So they can get massive amounts of rainfall that affect what's possible to grow. So that variation in rainfalls is pretty important in terms of deciding what species you might be able to succeed with growing. We've found big variation. Some of the tougher, drought tolerant species like Eucalyptus cladocalyx, we've tested it on higher rainfall sites. It just doesn't like it. It falls off. It doesn't like the humidity and too much wet. So you just can't move them around as much as you do, say, radiata pine. And this next slide, this is the most critical one. And this is about minimum winter temperatures, which I spoke briefly about in my video. And there's a huge difference in the minimum winter temperatures between the South Island and the North Island. And the colours demonstrate that. Really, the North Island, the coldest parts of the North Island up here in the central around the volcano area, that's Ruapehu, Tongariro, Ngārahoe, and up on the central plateau is this lighter blue. You look at the Southern Alps, which are an extensive part of the whole of the South Island. They're a massive fridge, or basically it's a deep freeze unit. That means that we do not have areas very much south of the top of the South. There's not many localities we think you could probably grow our species. People will find locations further south, but there's not the large extensive areas that the North Island offers that we've identified as having the most significant opportunity for our species. If you look at those minimum temperatures, those are July minimums. They're not how cold it actually gets. And to give you some idea, here in the Wairau Valley, where I am in Blenheim, we can get still down to -5 degrees. And at -5, that kills quite a number of the species that we're working with. You get to -8 or -10 as you go further up the valley, down on the valley floor, and it'll just blow things away. So while there's a Eucalyptus nitens resource in Southland, that's because Eucalyptus nitens is an alpine species, or it's from Tasmania as well in Australia, extremely cold areas that it can grow and tolerate in there, and it's well suited to Southland. It turned out that if you moved nitens, as was tested around Rotorua 15, 20 years ago, it actually didn't survive. It got very damaged by pest diseases and didn't like those warmer, more humid conditions. So understanding the genus and the species and where they fit into New Zealand, that's one of the big tasks that the DFI have taken on, is to assist people. It's a bit like viticulture or horticulture. You know, you can't grow avocados in Southland. You know, it's just a no-brainer. If you want to be an avocado grower, you've got to go to warm areas. So for doing well with growing eucalyptus, we're saying really that the North Island growers, they have the best opportunity.
Thanks, Paul. One last question, and conscious of time, as I say, this is from Roger. And Roger says, are there plans to produce growth models for these species and in different parts of the country? Paul.
Yeah, that's definitely the case. We've already got some early models that you and Mason and some of our PhD students have been developing. And what we've been doing is a major round of measurement work in our PSPs. And one of the next steps we'd like to do is take all that new data and run it through our models and start to develop, not necessarily different models, but at least understand the variation in productivity and opportunity that presents for growers.
Thank you very much, Paul, Clemens and Marco, for that. That draws to a close sessions 1 and 2, and we've got a 5-minute break now, so people can make a cup of tea quickly or have a bit of a comfort stop. So we'll see you in 5. Okay, hopefully welcome back. Very short 5 minutes, but hopefully you managed to grab yourself a coffee or whatever. We'll have to keep moving on. We're just a little bit behind time, but that's no problem. So we're on to session 3, and this is around the establishment and growing of ukes from a New Zealand perspective. And I'm going to now pass over to Paul again to introduce the session.
Okay, Chef, thanks. I'm going to go back to the NZDFI website and just use the website and once again give a little bit more insight into the availability of information to anyone who's a grower. So clearly for growers, this is, as I said earlier, where we've got the most extensive information available. There's a whole set of general guidelines that I won't click on. I'll just stay on this top page in the meantime and just take you through it. Understanding the right tree, right place, and why you grow eucalypts, which we've already talked about. You can revisit the vision and the strategies that we've got. But it's when you get down to choosing the right growing regime, that's where you'll find out about the opportunities for a peeler pole type regime, post and pole type regime, a saw log regime. Those are the 2 key ones that we've been doing some work on. But we've also given thought to, there's a lot of interest in continuous cover regimes, and can you have establish a forest and selectively harvest so that it's actually a continuous forest and providing an annual supply of logs and regenerating itself. And that's a natural system that they use in Australia for managing native forests in Australia, native eucalypt forests, and it's well proven there, and we see no reason why in New Zealand that can't be done. In fact, my own property in the Sounds, brother and I, Ash, we're already doing that, growing a continuous cover forest. And then we do cover off on permanent regimes. So this is carbon sequestration and the opportunity that there is to plant eucalyptus for a permanent forest and to collect or earn carbon credits under the ETS. When it comes to establishment, there's a lot of information about establishment, whether it's grassland or in pine cutover. We've got quite a number of information, including videos, to help show growers how you go about successful establishment on either of those types of sites. And critical, of course, is information on the various species that we're breeding and working with, the Sistuana, Globoidea, Quadrangulata, and Cladocalyx. All of those species now we have got improved material coming through our breeding program or in the case of plaited calyx, we had the benefit of work that was done by the Australian Low Rainfall Tree Improvement Group. One of the leaders in that was David Bush, and based in Canberra, and we've been able to source improved plaited calyx seed, which is performing pretty well in New Zealand on quite a number of our trial sites. So that range of information that you've got for growers, it further extends to, as I said, the properties and utilisation of markets, the xylogene brand, which I'll talk about later, the importance of form pruning. I keep losing my tab there. And one of the other things that we've also dipped into is the benefit of growing eucalyptus for the flowers that they produce, the nectar and the pollen that's available for bees, and also our native birds. A number of our native bird species benefit from flowering eucalypts. And for those who don't understand the classification of naturally durable timber, the Australian Natural Durability Standard, Timber Standard, that's also on the website. So that's where class 1, 2, 3 and 4, those are the 4 different durability classifications that are used, with class 1 being the highest durability and class 4 being the lowest. So you've got to get your head around understanding that durability classification, and then know that, you know, the species that we're working with, some of them are class 1, some of them are class 2. The class 2s are definitely not as long-lived as particularly in in-ground applications as the class 1s. So you really do need to know which one you're wanting to try to grow based on the market opportunity and the sites that you have on your property. So there's a fair bit to be learnt there. As I said, a lot of it on the website. Good place to start, particularly even if you're a forestry consultant and somebody's ringing you up saying, hey, what about growing these durable eucalypts? I've heard about it. I'll be frank, don't ring me first. Go to the website first, have a good look at that. If you've got any specific questions, I don't mind taking a call, but I get frustrated if people are trying to ring me up and they haven't even had a look at what's available. We put a lot of resource and investment into making this online. So I hope you find your way around it. Always welcome feedback. Got to compliment and thank Harriet. She's the one, Harriet Palmer, who has put together the website and manages it for us, and I think she does an excellent job.
Another stop in our virtual field trip, and we go to the Pukaka forest.
We've reached the afternoon and we're at stop 3 on our virtual tour. Hope you've been enjoying where we've been so far. Where we've moved to is the northern side of that big Wairau Valley that I was talking about earlier, into the higher rainfall hill country that formerly was farm, but in the 1960s and 70s it was identified as having potential for pine forests. And at the time, in the 1970s, the local councils formed the Marlborough Regional Forests as a group to invest in pine forestry, and bought this land, and it was planted. So in 2003, I was able to approach Marlborough Regional Forest to discuss the opportunity of planting trials of some of the new species that we'd identified for the possibility to produce vineyard posts. One of those was Eucalyptus bassistoana, and this tree right beside me is a specimen from the small stand that we planted back then in 2003. Today the trees are 18 years old, and we can now see the provenance. In other words, what is the genetics and how good was that Central Coast seed lot, because it was unimproved, basically straight out of the forest over in Australia, collected by a seed collector, gone to the nursery to produce the seedlings that were then established to create the stand. It's a fine example of an unimproved seed lot, mainly because it shows a huge variety of both growth and form, and that if you were to look at the wood properties, you would also find a lot of variation. Okay, let's have a look at some of the variation that I've just talked about. This tree here on the right, this would be a top tree. It's an elite tree, is what we'd call it if it was in one of our collections for breeding. It's gun barrel straight. I haven't measured the height, but it's well in excess of 20 metres. It's got reasonably good branching, and it's relative to the other trees, it's already got a good diameter. As I've said, we don't know what the heartwood properties are like, but if we were able to take a core, we could find that out. If we were looking for candidates in a breeding program and we were starting to make some new selections, we actually could take seed from this tree and introduce it now into our breeding program because we do know its provenance. By comparison, this tree here, while it demonstrates excellent productivity because its diameter is similar in size or even larger than the tree that we've just looked at, unfortunately its lower bole is sinuous or wobbles, it's not straight, and then once you get above where the pruning finished, there's a major fork to the stem, and that repeats itself further up, and that replication of forking up the stem is a genetic trait that we want to eliminate, and so this tree would be excluded from the breeding program and would be thinned out of, and entirely that family, if it's family related, which is what we learn, then these are the types of trees that we rogue out of the breeding population. This stand was planted actually in a small, what was formerly a paddock, a grassed area. It hadn't been previously planted, so the area was spot sprayed prior to planting and established. Generally in spring, you plant eucalypts in spring, especially on a flatter site like this where you can get frosts later on in the season. And it was planted at a reasonably high stocking. The intention was to set it up with the potential to be able to grow some vineyard posts, as we've discussed at the vineyard, and to give us an early indication as to whether Eucalyptus persistoana was a suitable species, both for growing in these types of environments, as well as then to process into posts. The management by Marlborough Regional Forests has been excellent. They've come in and undertaken, the initial operation would have included some form pruning on most trees to tidy them up, because a lot of unimproved Eucalyptus persistoana has double leaders and forks, and it's a pretty ugly tree, and can be. And then following on from that, they would have done some thinning to open the stand up and provide more light and room for some of the better trees to grow. And then they've pruned most of the trees up to at least 4 metres, some of them up to potentially about 6 metres. And so there's some good clearwood butt logs that are on some of the larger trees. You can see they're already under development. So that pruning or that silvicultural treatment has the stand now where we've got a mix of some larger, better formed stems. You can see that one standing in the light over there, as well as there's some stems which have got some major imperfections, a twist and the like, but there may be some reasonable straight logs further up that stem. The stand, as I've said, is well managed, and it really, the opportunity it presents is to be managed in two ways. One would be to come in and undertake a full harvest, and some of the trees would go into vineyard posts. Some of the larger trees could be peeled, go to peeler logs, and be part of developing a high strength LVL business. Or alternatively, because it's a flat site and there's easy access, thinning of all of the smaller trees as well as some of the larger trees, and leaving the very best trees to grow on for large saw logs is another opportunity. We've moved up the Pukaka Valley to another part of the Marlborough Regional Forests, and you can probably hear in the background there's a machine working that's cleaning up following a recent pine harvest, which is spread out on the flats here in front of me. But where I want you to look is onto the lower slopes and behind. And you can see that there's a mixed trial here planted in 2005 by Marlborough Regional Forests in collaboration with Vineyard Timbers, when we were already identifying some key species that we thought had a real opportunity to be grown, not just in some of the better sites where we've been, the Eucalyptus persistuana there growing on river flats where it's very fertile, but also species that would grow up onto the slopes, and the soil is a lot poorer, especially in this Pukaka Valley. And so on our right hand side over to this area is Eucalyptus quadrangulata. In the middle of the stand, the lighter colour, and the smaller spindlier trees, they are persistuana, not growing as well as they were on the flats in the other site that we saw, but they're still surviving nonetheless. And then over to the left hand side is Eucalyptus globoidea. Being able to work with Marlborough Regional Forest was important in that we were able to investigate what was required to convert from a cut-over pine forest to a eucalypt forest. And this Pukaka Valley, it had been planted in the late 1970s, and so at the time that we were investigating these species in 2003, 2004, these slopes above us were being harvested. By working with Phil Woodward from Marlborough Regional Forests, we used the same approach to site preparation that he was already using for preparing the site after harvest to replant in pines. The cut-over area can be sprayed with metsulfuron, and following a stand-down period of 6 months, you can then be planting straight into that area with pines. Or, in our case, we were able to plant our eucalypt trials. After planting, once again we followed a similar regime to the persistuana that we've just looked at. There was some early form pruning to make sure that the better trees did develop a single leaner. The stand was then left for about 5 years before a first pruning lift was undertaken, and then a second pruning lift followed about 18 months after that, because the trees have been pruned up to 5-6 metres in height, and it was thinned down to about, on the balance, 500 stems to the hectare. So while this is a steeper site and more difficult to possibly production thin, the opportunity is still there, because actually above the stand is a road that joins the main road and runs right above the top of the stand, and we have access along the base of the stand. So an opportunity in the future is production thinning to get polewood for the vineyard posts and grow on the stand for larger saw logs. I think it's a really exciting opportunity that Marlborough forest growers have to look at some of these pine forests within the region, particularly those that are clustered near the Kaituna site that we have identified as a future processing site for a sawmill and a post-peeling mill, and to progressively plant a new resource of hardwood forests for the region, so that we can see these future industries and future generations can benefit from the availability of high quality, durable hardwood.
So following on from that, I would like to share a few thoughts about what's involved to establish such a hardwood industry from almost nothing here in New Zealand, and to be successful in that. And it has to do a lot with the supply chain in this industry. And it's quite complex in terms of time, but and also in steps involved. So from the conception of the idea to produce durable timber here in New Zealand, that was 20 years ago, to where we are now, having the first improved plants available to be planted, that was 20 decades of work. And it started with trying out certain species, which we tested under New Zealand conditions, and then establishing a breeding program to make sure that we have also a quality supply of plants. So now after 20 years, we're at the stage where we actually need to establish the forests. So we are now working more and more with landowners, with growers. We need to find the labor to plant and establish those forests. We need to think more about the management and the growing regimes of these plantations. And it's not like we are stepping in the dark here. There's quite a lot of background knowledge already there, but we are now in the position to establish more silvicultural trial and fine-tune our recommendations. Now then, obviously these forests need to grow, and depending on the target product, that's another 15, 20, 30 years in the future when we will then be able to harvest our first trees. So that's 2 decades plus another 2 to 3 decades. Now only at that stage then, we obviously need to harvest and transport them. Then it's the whole idea of having this resource not scattered around of all of New Zealand, but really agglomerated in certain regions will be very helpful, because it will bring down our transport costs. And having already identified sites where there is processing capacity, or where there's a site where a processing mill can be built, and that's very helpful. And the other thing you see here that obviously we have different target products. There will be different wood processing mills needed, but they are not necessarily large scale. We always have small to medium scale options. And even if you like micro scale options where we can go onto a farm and process there with a mobile sawmill also. Okay, so then we also, and lots of these industries which we are targeting already exist in New Zealand. So we have a post industry based on radiata pine. We have specialty sawmills here, and we have LVL and plywood industry as well. And then there are obviously the products which come out of these mills. And again, I think what's quite worth noting is that we are not really trying to work with really newly developed products. These are all products which have a long track record of use. And I don't think there will be any need to create demand for it. We have already a lot of demand for naturally durable posts, but we simply can't supply them. I don't think it's a problem that we find a market for these products. Now you see there are many steps involved and in the wood supply chains and in forestry, and that means there are also a lot of people involved, from researchers over growers, farm foresters, and contractors. And there will be all the wood processing industries. There will be merchants and also consumers and architects, and likewise there's the government agencies or local government which is involved as well. And while and I have to say that the NZDFI has support and stakeholders and interest from the whole process chain. So we are already talking to a lot of people, and it's one of the key things to be successful is in establishing such a hardwood industry in New Zealand. Okay, with that, I would like to hand over to Shaf to moderate another question and answer session, and then you can try and see how many questions we have.
All right, can you hear me, Clemens?
Yes, I can.
Okay, so far one question which came fairly, oh no, maybe there's more now. Sorry, pardon me. So the first question is from Robert Hickson, and it's to Paul. Paul, are you finding significant differences in species performance across the 12 trial sites? We're in the Wairarapa and hoping to plant this winter. You there, Paul?
Yeah, I'm there, Chef, just unmuting. Yeah, thanks for that question, Robert, and welcome along. So we've got more than 12 trial sites, but but we don't have 12 in the Wairarapa, so I'm not sure quite where that figure came from. But putting that aside, we certainly are seeing significant differences in species performance between various sites. As I've already indicated, rainfall and humidity do play a hand in influencing even just the vitality, you might say, of some of the species that really are dryland species. So the likes of Eucalyptus tricarpa and Cladocalyx. If you're in the Wairarapa, and in fact, there are old stands of Cladocalyx in the Wairarapa, where if you're up on the hills out towards the east coast, well away from the Tararua ranges, then it's potentially a successful species. If you're nearer the Tararua ranges, with significant higher rainfall in some of those areas, then depending on the soil type, you'd be looking at Basistuana or Eucalyptus globoidea. We're finding that actually Eucalyptus globoidea, by and large, is performing across most of our trial sites. The most limiting factor for most of the species, though, is poor drainage. So if you've got soils which in wintertime can end up extremely boggy and wet, then you've really got to be careful about what you might be planting into those kinds of sites. So there's a sort of a regional variation to look at, and then you've got to look at that site variation. And I know that sounds more demanding than say planting a pine tree, but there's no shortcuts here. And that's why I urge you to have a look at all the information about all of the species and try and get an appreciation yourself based on your own site as to what you think might be the most suitable species to grow.
Thanks, Paul. This is a good question from Belinda Miller. And I guess, Paul, in the first instance, maybe you might like to answer this. And she says, following first rotation, is replanting required, or can a grower simply leave the trees to coppice for the second rotation? If so, does this reduce second rotation growing time?
Well, thanks for the question, Belinda. I'm not sure is the short answer, because we haven't been able to have the time to undertake the kind of research where we would grow a crop, cut it down, coppice it, and then measure it for a second rotation. There is evidence from other work done internationally that if you do grow a coppice rotation of eucalypts, and I can't say which species and whether this is a rule, and perhaps someone from Australia who's got some experience in this may be able to contribute, but that you can definitely get faster growth rates in that second coppice rotation and potentially for a third, but the vigor of the root system does decline with repetitive felling and coppicing. The other issue that you have if you're going to pursue coppice as a system, and I'm not saying you shouldn't, but is that you don't get the improved genetics. And our breeding program, it's ongoing. We're moving forward progressively with trying to improve the genetics of what's going to be available, so that if you planted, for example, this coming planting season, you were growing even a short rotation, say pole crop that you were wanting to fell between say 15 and 18 years, I would like to think that in another 15 to 18 years, provided we continue to get sufficient funding and resourcing and the capability that we need to continue the breeding program, that the genetics of what we'll have available, that you could consider replanting instead of coppicing, would mean you'd get definitely greater productivity on your second rotation, and potentially better or much more improvement in the wood properties. So as I said, you can do it, and certainly in some situations, I know of some of the waste water in Marlborough from vineyards. They're using small eucalypt plantations for firewood, and they've been pumping water onto those plantations to irrigate the wastewater out of the wineries, and then coppicing the eucalypts for firewood, and they've been doing that for years. So there's a lot of options and ways forward. Yeah.
Okay, there's a question from Kevin Harding, but there's an associated question from Joanne Lewis, and you've partially answered it, Paul. Joanne had asked, are you managing coppice regen and multi-aged forests? We're not, but I think the second part of a question, and it might be anecdotal, have you noticed some species are more tolerant of shading and competition than others? Have you seen anything that might point that in trials that might point out certain species as being more shade tolerant?
Yeah, to be honest,
I don't
yes,
know. Really?
I don't know. Yeah,
okay.
I wouldn't hazard a comment on that. Yeah.
Okay. All right. Thanks, Paul. You're in the gun again from Kevin Harding. Hi, Paul. Although your vision is reasonably modest to establish 5,000 hectares for a region, no doubt it will attract some negativity from some in the agricultural community if large plantings of trees are established. Would you agree that farm forestry plantings have a big role to play here, as the plantings will be smaller and on a smaller scale, e.g. 15% of total farm area, with many additional benefits to the rural enterprise for livestock production, erosion control, water quality, etc., etc. Yeah, also natural pest control by promoting local bird life and favourable insects. Cheers, Kevin. Did you get the guts of that question, Paul?
Well, I just agree. I definitely agree, Kevin. I mean, our goal is a mosaic, if you like to think of plantations. We think there should be a minimum area. Certainly the radiata industry's indicated, you know, from felling small woodlots, because there's a lot of forestry, farm foresters planted in the 90s. And if you plant under, say, 5 hectares, and particularly in a difficult part of the farm, the economics of harvesting that kind of area, when you've got to take fences down and perhaps cross a creek, and suddenly you've got to put a bridge in, or a temporary, crossing, etc. Those are all challenging questions. I think the farm forester themselves on their property needs to appreciate. But there's plenty of farm foresters. The New Zealand Farm Forestry Association, there's a lot of members. I've been to their properties. They're already demonstrating what's possible with pines and other species. Some of them have got eucalypts. Some of them have got more than 15% of their farm in trees, but their farm business is going really well as a consequence, because of those benefits that you have already indicated in your question, Kevin. So we're all for this. I'm actually frustrated in a way that we haven't really got, aside from farm foresters, we just need to get that message out to a great more of our farmers and get them on board. That's a big ask to try and do that, but certainly that's partly, I'm hoping some of the people here today even are in that category. Perhaps Richard, who had his question, he may be one of those. So we definitely want to see more trees in the New Zealand landscape.
Thanks, Paul. I've got 4 questions. I'd like to, if we can, we'll knock these ones off and then move on. This is a question possibly for Clemens. Hi, what phase of Clemens' flowchart are you on? And how far away is large planting uptake from commercial foresters?
We are right at the first year, or this was the first year where we have actually sent out or sold improved plants. on a commercial basis. And so that's where we are right at the start of establishing those forests. And yes, there's interest from commercial foresters. The bottleneck at the moment is we don't have enough plants to meet the demand.
Thanks, Clemens. Look, that also answers Robert Miller's question. Rob, I'm hoping you're happy enough with that. I'll say, as a seed producer and propagationist, it's not easy. We have a number of seed orchards in, first generation selected material. Some are seeding, some are not. Eucalyptus persistoana is slow compared to, say, Cladocalyx. We've invested quite a bit of time and effort in clonal propagation, and with the support of MPI and the Billion Trees program. And, you know, the results have been a mixture. Some elements of it are really, really good. Other elements, clonal propagation suffers from possibly the same issues that we do with other species radiata. It's very family specific or clonal specific. And so we're learning a lot. So, you know, we would hope to start being able to produce more of this material in the future as we get new selections. But there is that lag, and I know it's frustrating. It's very frustrating for us as seed producers to have this when we've really got a good story to tell, you know, the nation. So bear with us. We're doing everything we can. Establishing more orchard, it just takes time. If that's okay, Dean Severino asked the question, are you in competition for land with the Billion Trees program? And I'd say no to that. I don't think we're in any direct competition.
Well, Chef, what I can add is actually some of the people that planted last year, they actually got grants under the Billion Trees program in order to plant a tree. So it's actually a cooperative arrangement for us. And I'm very keen the government would continue with the 1 Billion Trees program, but that's been discontinued at the moment.
Okay, I'm going to finish off with another question from Kevin, and it's actually to Belinda. Belinda, Kevin's got a comment regarding coppicing. Hi, Belinda. I agree with Paul that if you have better genetics, you would normally replant rather than manage coppice. And it's very important to manage the coppice to reduce it to only 2 stems per stump to avoid competition amongst stems and reduce the tendency to get a limiting sweep at the base of each stem. Cheers. That's from Kevin, Belinda. And I think that just is a good spot to time to draw to a close this particular Q&A session and move on to our last one of the afternoon, session 4. And that's really the linkages and between the wood quality research, the breeding program, and we've started to touch on the production of improved planting material. So I'll pass over to Clemens for an intro.
Yes, just a few words before we go to our next stop in our virtual field day. The R&D program of the NZDFI can be broadly structured into 3 areas. One is breeding the trees and propagating them, and then growing the forests, wood processing, utilizing the trees, and then also establishing the business case. And the overall bigger headlines is that we are in a breeding program. We continue phenotyping, producing new crosses. We have started this genomics, and as you heard from Jeff, we are doing a lot in the area of seed production and try to increase our capacity there and do it better. We also look at producing clones as well. And there's growing the forests, and there's obviously the silviculture, which we had touched on. No, we have not much experience with coppice and mixed species forests, but it's certainly something on our radar, which we are now able to establish our trials because we have the plants available. We know already quite a bit about site matching, But one other thing is that we need to improve or continuously improve our growth models. And we are or have developed really new growth models, which also take into account the hardwood, because we are not interested in the size of the tree. We are interested in how much hardwood is in there. And that's a quite different question to ask. And last but not least, it's to do with forest health. So we're developing a pest management plan. So how to manage pest incursions and when to do that. And then there's utilizing those trees, and our main feature for the wood is durability, and we want to ensure that we supply a high quality naturally durable product. So we are looking into how can we ensure that quality control into a grading system for durability. There's a lot which can be done in solid wood processing and improve that, but we are not looking at really new products here, and there's a lot to be learned from other places, from what is already known, and there's a lot of really excellent work, for example, going on in Australia right now, peeling such trees for veneers and for engineered wood products. Residues, we need to find an outlet for residues. Not everything of the stem will end up in our targeted products. And we have discussed a little bit the option as a fuel, but we might be able to find even higher value products, or a step before, and can burn it afterwards. Non-timber products are on our radar, and that's biomass for fuel, but also eucalyptus oil, for example, where we have also made a start. And last, there's the business case, where we look into the market, what opportunities are out there, product standards, carbon sequestration is quite a bit of a topic because of the fast growth rates and the high density. The potential of our species is not necessarily reflected, or is not reflected in the New Zealand sequestration tables. Social license to operate is important. There are some concerns about wildings, fire threats, water quality, and we obviously need to address those. And there's the extension work, like what we are doing today, getting the message out to growers, and that there's this opportunity. So who is in the team? There's the Marlborough Research Centre, which is really attached to the New Zealand wine industry. It's hosting the management of the NZDFI. It is also where we run our contractors are based, and does a lot of the outreach activity. Then there's Proceed, and they're in charge of all the propagation work and making sure that there are these plants available for foresters to grow. And then there's us, the New Zealand School of Forestry here at the University of Canterbury, where the NZDFI is a quite large research project for our department. Most of our academics, or my colleagues, are involved in it. They provide expertise from wood properties processing, over tree breeding, tree health, growth modeling, site matching, and also the economics of it. So we are not doing that all by ourselves. We have collaborators, and we are also aware that there's a lot of good work going on overseas in Australia, in South Africa and Chile, where we can learn a lot from, and we'll need to collaborate a lot more in future, because there's so much more to be learned. So with that, I would like to take you to one of our breeding trials, where we get a little bit more into the detail of what are we actually doing in our breeding program, and how do we get into the production of our improved plants. Hi, now we are in a 2010 breeding trial for Eucalyptus bozesuana. It's called Graven's Road, and we use those trials to find out which are the trees that have good genetics for our purposes. And for our purposes, the trees should be straight, the trees should be fast growing, but the fast growing tree is not necessarily the one we want, because in our case only the hardwood is naturally durable and the sapwood is actually not naturally durable. And there's quite a bit of variation in the hardwood in a tree. So I have discs of two trees, and they are more or less the same diameter. And we can visualize what the hardwood is by putting some pH indicator on it. And then we have one tree which has much less hardwood than the other tree, and this tree would be much more valuable to us than that tree which has less hardwood, even if they look the same. Or it can be more extreme. We can have actually smaller trees which have in some cases more hardwood than larger trees. So just like a forester going into a trial and measuring the diameter of the tree doesn't really help us much. So how actually are we doing the assessments for our trees? We need to take wood samples. We need to take wood samples when the trees have developed hardwood. And we have done that in this trial already a couple of years ago. We have developed this handheld tree corer, which is basically a hollow drill. And we can very quickly, in less than a minute, get out a corer in a very easy fashion. And then once we have the cores, we have a wood sample which we then can measure for the amount of hardwood in them. So we have the core sample, and we know which tree it comes from. We put the indicator on it. We know how big the tree is, and we can also measure how much hardwood it has. If we do that over very many trees, of which we also know the genetics, meaning from which tree they come, which heritage they have, then we can calculate the heritability, the genetic control of the trait, and it's quite heritable. So there's quite a bit of genetic control in the amount of hardwood in our trees, and we have now assessed six trials of Eucalyptus bozestuana, and we have done already some selections of this species, and trees which are now available commercially for planting, they are basically selected for good hardwood content. We have done the same thing for Eucalyptus globoidea as well. Okay, apart from how much hardwood is in our trees, then we also need to know how good is the hardwood. There's as much variability in the quality of the hardwood, the durability, as there's in the amount or any other traits in the trees. So there's a shortcut, if you like, and what makes the wood durable is mainly extractives which are deposited into the wood, which gives it the color in the hardwood, and also which gives it the durability. These compounds, they can be extracted, and some of them have fungicidal or insecticidal properties, and they provide the decay resistance. So we can extract these compounds. It's a bit like making coffee or tea. We grind the wood up, put some hot solvents over it, evaporate then the solvent, and we can measure the mass which is left over, or just look at the color of the extract. And here I have two examples. So that's the extracts of two timbers, and you can see one is much darker and the other is much lighter. So there will be much more extractives in this sample than in the other. And we can bet that the high extractive content will result in timber which is much more durable. We have shown that there's a lot of variation in the amount of extracts in our trees, between 2% and more than 20% around here. And we have also shown, together with some colleagues from Australia, Laurie Cookson, we have shown that samples with a high extractive content have also performed very well in one of these fungal decay tests, where we exposed wood samples to wood decaying fungi and measured how much mass is lost. Extracting our wood to measure extractives in that way is also very labor intensive. So we came up with a quick way of measuring it, and we can use infrared spectroscopy, which is basically looking at the color of light, but in frequencies which we can't recognize with our eye, and but machine can, and then these correlate to the chemistry of the wood, and we can do this spectroscopy assessments within seconds, non-destructively on wood. And we take our cores from the trials, bring them to the lab, and then scan them with the infrared spectrometer. And we have calibrated it against our extractive content measurements, and we get quite accurate prediction of extractive content. With that, we have thousands of trees measured, characterized for extractive content, and we could again calculate the genetic control over it. And the amount of extractives in our trees is highly heritable. Like you see behind me, all these variation in the trees in shape and in size, that's under genetic control, and as is the extractive contents and the durability in the trees. And therefore it's very important for us that we have a strong breeding program to make sure that we select the right genetics to be planted in the production forests, and that's happening from this year onwards. We have improved plants available. So when they are then ready to be harvested, we are sure that the products which are manufactured, like the posts for the vineyards, will also perform, and the customers are satisfied with our products. That's important in particular for young trees, because we know for young trees the wood properties are not ideal, and we know that for radiata pine the wood is not stiff and dimensionally stable as a young age. But it's also true to some degree for natural durability. If you look up the natural durable standards, they state that the inside of the tree, the hardwood, the inner hardwood, is less durable than the outer hardwood. So if we want to produce posts from our younger trees, we particularly need to make sure that we have the best genetics in our trials. And already papers or researchers over in Australia have shown that these trees do exist. There are trees which at young age already produce highly durable wood. While we can make sure that the trees which go into our plantations are best genetics which we can find, we can also think about, is it possible to grade the timber for durability? And because we have now shown with near-infrared spectroscopy, we can do non-destructive quick measurements of durability. I think there's a real opportunity that we start to develop a grading standard or a quality control system for our durable timber as well.
In planting a breeding population or a progeny trial, collections have been made in Australia of from individual trees that we've identified now and pedigreed as the trial was planted into the various families. So the mother trees in Australia have produced sufficient seedlings for us to establish these trials at scale. And the Cravens Road trial has, this section of it has 60 different mothers that have had the seedlings grown and evaluated for us to identify then these elite trees. So this elite tree, having found it in our trial, it's a very important step of being able to take signwood, which is the upper stem, a selection of branch, normally in January and February period, and that is collected by Proceed. Paul Schroeder comes up from Amberley and he takes those young sign shoots and grafts them onto rootstock that he's had grown in the nursery, and then that rootstock, those grafted trees have been used to establish Proceed's seed orchard. In the seed orchard, when you bring together the elite trees from all of those different families, and we only choose the best families, so not every family goes to the seed orchard, but once they're in the seed orchard, that's where the real major genetic improvement occurs, because those various families can flower and we can get outcrossing between those individual trees that then produces new seed that we hope has some of the best and even better genetics than any of the original parent trees. What's been interesting about this Cravens Road site is it's actually within the stop banks of the Wairau River system. So behind me there's a big stop bank, And in July this year, the water was lapping at the top of it. We had a major flood event that had water flowing up to 3 metres up the stem across this entire trial. There's trees further up in the stand that have been pushed right over, but it is outstanding to see this trial after that event has survived it as well as it has. I was distressed to know the flood was happening when it was, but now that we've seen only 3 months later, you'd hardly believe that it had occurred. That's interesting because we see Eucalyptus persistoana as having a place in New Zealand's riverbed systems. On these fertile, silty, even quite gravelly soils, it seems well adapted to being able to thrive and even to handle these flood conditions. So we this year established with the Hawke's Bay Regional Council a similar trial in the Tukituki riverbed up near Waipukurau in Hawke's Bay, and I'm pretty excited to see what happens when they get a flood in that trial as well.
Thank you. And now we will hand over to Paul to have another few slides.
Sure, Clemens. I'll just share the last couple of slides here I've got to wrap up with. So just a brief look at some of the additional benefits, and some of this we've touched on already, that we see as needing future research. I've already talked about the opportunity for carbon sequestration and eucalypts having very fast growth rates and yet producing this dense timber. If you look at what New Zealand's Climate Change Commission has come out with a push for 300,000 hectares of new forests in the next, and this is not native forests, this is 300,000 hectares of exotic forests in the next 10 or 15 years. That's why we really want to get our species into the mix. We think there is significant gains in the carbon sequestration rates that New Zealand as a nation could achieve if we extend to planting the resources that we're promoting in our target regions. There's the opportunity for biofuels and bioproducts, as Clemens has alluded to. The opportunity that, from a soil conservation point of view, one of the things about eucalypts coppicing that may be very advantageous is that the root systems, because they don't die and can regenerate and grow again, unlike radiata, that we won't have this window of vulnerability on steep slopes that does occur in some of the harvesting of larger catchments and unstable hill slopes throughout New Zealand. And that's occurred, we've had some major slips and post-harvest events, which sure they're caused by some of the massive rainfall events that we've been getting, but we think there's an opportunity to look at the potential in some of those very vulnerable areas to move to planting eucalypts as an alternative. I've talked about the biodiversity value, the pollen and nectar for native birds and bees. We need to do a lot more work in forest health and biosecurity, and we're very keen to not wait to sort of see all the planting done before we encourage more processing. As I've said, some regions have been getting underway for planting. There is an emerging resource, and so that's a smaller scale wood processing industry that's out there already, being able to work with them and get this wood being harvested, getting a reasonable price to the growers and being able to get the wood to market. The last point I want to make is about the Xylogene brand. So this is our branding of our germplasm, our improved trees. You can shorten it just to the XG brand, the extra good for short. The brand is being used to promote the work that we've done to trademark our stock in the marketplace. And everything that we're selling now, we're looking to collect a royalty of 20 cents on the sale for continuing our research. It's a challenge to get, been a massive challenge. One of the biggest jobs I've had in my working career has been maintaining funding to continue our program. And so getting into a position where at least we are getting a reasonable income back off some of the sales is a key to the long-term future of the research program. And we believe the brand's got a huge opportunity to add value to the future products that are sold from the forests that are planted. And so I can see a cooperative type venture, or even just the company venture that ends up processing the wood, certifying it, using the XG brand as a means of taking the story, the whole story, the supply chain story that we've developed into the market, to guarantee that people know if they're buying XG wood, it's definitely the stuff that's come from our breeding program. So in spring last year, as Clemens said, we started planting with 240,000 of our first generation nursery stock. We have over another 300,000 stock under production for this year, and all of those are booked. So unfortunately, anybody who's looking to plant this year, I can only add you to our reserve list at this stage, but really new orders have to be taken for next year. So that's a great position for us to be in. But as Shaf said, we don't want too many people clamoring at the door wanting plants, because we've still got to build up our seed supply in order to build up the availability of plants. But we have some confidence we can definitely go to market with the 300,000 that we've got this year, and we want to try and increase that to 500,000 next year. And then as some of the trees that we are collecting seed from get to a bigger size and we can produce more seed, and the seed orchards come on stream, or we're successful with clonal propagation, we want to grow to producing at least 1 million up to 2 million plants a year. So back to you, Shaf.
Thanks, Paul. So we've got a Q&A session to come, but it's down to me just to quickly wrap up, because I know a number of you are probably already having to depart from the workshop. I do appreciate the comments that have been coming back, very positive, very supportive, and we hope we can draw upon your support going forward. The issue, as Paul has alluded to, is we've got a program. It's driven by products. It's very much market focused, and we need as many income or streams of money in order to support it going forward, or in terms of research. There's a lot of research to be done, and it's not lost on me. I mean, we're close to Australia, and we have issues with pests and diseases, and that's a very important part of our program, both from a breeding viewpoint and just through management of pests and what have you. I'm not going to try and wrap up or summarize what's been said. I think it's been excellent. It's been obviously a bit tricky. We've never done something like this before, but apart from the odd myself trying to find the unmute myself, it's largely gone very well. And that's really a testament to the people that have spoken today and the ones behind the scenes. And so I really want to thank Paul, Clemens and Marco, and our other speakers, that were on video. Fantastic. And some of you may be still on LinkedIn. Thank you so much for your efforts. A big shout out to Harriet Palmer. She did all the coordination, the planning and the delivery of this workshop, and she's done an excellent job. To Daniel Bosnowicz, who's, if he doesn't get his PhD, he could go into movie making. I'm sure Peter Jackson would like to see you working for him, because you're an excellent film man, Daniel. Thank you for all that video work that you did. To Susan Foster at the Marlborough Research Centre, she handled all the registrations and everything, and much appreciated, Susan. And then the School of Forestry also for providing the facilities, the support, especially from Mika Holzenkampfer and Monica Sharma for all that tech support. It largely went really well. Fantastic job, guys. And then I just want to share, finally, just share a screen if I can get it up and going. He said, where are we? I can't quite see it. I knew I was going to get caught out on this. Perhaps
share screen.
I've got share screen. I'm just looking for my Zoom. I'm not going to worry about it. I'm sorry, because maybe Mika, if you can you
share? Yeah,
share it up? That would be awesome. Thank you. Great. That's exactly what I'm after. Look, to the partners, the supporters, and the 37 landowners Paul's already talked about, thank you so much. I mean, it's quite a broad church of groups, and we wouldn't be in this position today if it wasn't for your support. To the team, Paul's already alluded to it, at Clemens as well. There's quite a team, yeah, and you can see them there. Obviously, the School of Forestry, the University of Canterbury is so important to us, and it's great to have the skill sets that are available. And you know, the 14 PhDs and 8 masters and what have you. You know, there's been some really good PhDs and that come out of this program, and I'm really keen on supporting the school. And so, you know, there's still a lot of work to do. And finally, I want to draw your attention to our koru. And this is taken from our website. So a number of you would already have seen it. And it sums up who we are, where we're going, and our commitment to New Zealand's future, because that's what, you know, I think that's really important to us, to Paul, to me, to the university. It's all about supporting our country, supporting our industry. And this is taken, I'm going to read this piece. It's taken from the website, talks about the koru. And if you'll just bear with me, I just want to read it because I think this is really what it's all about. The NZDFI koru encapsulates our long-term vision for sustainable hardwood forests and associated benefits in New Zealand. It shows how from small beginnings, our vision has evolved to encompass a large range of economic, environmental, and social gains for regional economies. Our koru symbolises the new life, the strength, and the perpetual growth of the NZDFI. Our mission is to enable the development of sustainable hardwood industries and to perpetuate that growth. We see durable hardwoods as a key element of New Zealand's new multi-regional circular bioeconomy. I think that really sums up everything for me, the day and what have you. And I just want to, we're going to go into a quick Q&A for those that have questions. As the odd one there we'll get to, but I really want to thank you for your participation. I know there's a feedback survey there, and please, if you could send that in. But thanks very much to all of the participants that have put aside the time. It's a great story, we believe, and I trust that you will go away with a better idea of what the NZDFI durable hardwood program is all about. So thank you very much for your attendance. Now, I will just flick back to the chat, just see if there's any questions. Look, lots of comments about the quality of the seminar. Thank you so much. I'm just going up just to make sure that we haven't missed any, because I'm sure there was at least one question there that was asked. Right, no, I think we're actually all good. I think we've answered all of the questions. All the other comments here are all thanking us for the excellent presentations and discussions. So we appreciate that feedback. So thank you very much. Here we've answered, we've done it. That's it. So thanks very much again, everybody, and I wish you safe journeys. Cheers.
Thank you, Chef.
Yeah, thanks, Chef.
Yep, thanks, Chef.
Nobody wants to leave. They've enjoyed it.
I'm leaving.
Chat to many of you that I can see there. Really good to see so many people have been part of the program involved, and we'll see you. Hopefully we get through the Omicron. We'll be back out there doing real live field days than the online stuff. But hey, if we have to, we'll do it again. Yeah, great. Thanks.